Welcome back to G Fun Facts Online, the place where we dive deep into the wonders of science and technology. Today, we're plunging into the abyss, the vast, mysterious deep sea. Imagine trying to find your way in a place where your GPS is completely useless. That's the everyday reality for autonomous underwater vehicles, or AUVs, our robotic explorers of the underwater world. Water, especially salt water, plays havoc with GPS signals, often blocking them entirely. So how do these incredible machines navigate the dark, unmapped expanses of the ocean floor, dealing with unpredictable currents, tides, and bizarre landscapes? It's a massive challenge, but recent advancements in AUV technology are truly mind-blowing. We're talking better energy efficiency, super sharp sensors, and smarter decision-making thanks to intelligent algorithms. This isn't just cool tech. It's vital. AUVs are becoming indispensable for scientific research, keeping an eye on our marine environments, national security, and even the new frontier of deep-sea mining. So let's get into the nitty-gritty. How do these AUVs actually see in the dark and know where they're going? First up, we have Inertial Navigation Systems, or INS. Think of these as the AUV's inner ear, using accelerometers and gyroscopes to track its position and orientation. They're the foundation of AUV navigation, but there's a catch. They tend to drift over time, meaning tiny errors can add up, leading the AUV astray, so they need help. That's where Doppler Velocity Logs, or DVLs, come in. These gadgets are like the AUV's personal sonar speed gun. They shoot sound waves at the seabed or particles in the water and measure the change in frequency, the Doppler shift, of the returning echoes to calculate speed. When a DVL can keep a lock on the seafloor, its navigation deviation can be as tiny as 0.05% of the total distance traveled. That's incredibly precise. Then there are Acoustic Positioning Systems. Since radio waves don't travel well underwater, AUVs use sound. Systems like long baseline, LBL, short baseline, SBL, and ultra-short baseline, USBL, use underwater sound beacons or transponders like underwater GPS satellites. For instance, USBL can update an AUV's position as it descends until its DVL can lock onto the seabed. And there are even newer ideas, like synthetic long baseline, or SLBL, which uses a single acoustic transponder as a fixed reference point for high-accuracy navigation in the really deep sea. AUVs are also master mappers. They use various sonar systems, like side-scan sonar, multi-beam echo sounders, and sub-bottom profilers, to paint detailed pictures of the seafloor. This leads us to terrain-aided navigation, or TAN. With TAN, the AUV uses these maps it creates, or pre-existing ones if available, to figure out its location by matching what its sensors see to the known terrain. Super useful when there's absolutely no GPS. Now for something truly futuristic: Simultaneous Localization and Mapping, or SLAM. Imagine being dropped into a completely unknown, dark room, and having to draw a map of it while also keeping track of where you are on that map. That's SLAM. It's essential for AUVs to explore unmapped regions truly autonomously. Scientists are even working on cooperative SLAM, where multiple AUVs work together to map areas faster and more accurately. And of course, we can't talk about modern robotics without mentioning artificial intelligence and machine learning. AI and ML are revolutionizing AUV navigation. These smart systems allow AUVs to learn from their surroundings, adapt to changing conditions, optimize their routes, and dodge obstacles based on past data and real-time info. AI helps them make smart decisions on the fly, boosting their autonomy. It also crunches the massive amounts of data from sensors super fast, helping to identify objects and features. Think about the Mars Perseverance rover and its terrain relative navigation. Similar AI-driven systems are being adapted for AUVs to autonomously figure out where they are and steer clear of hazards. Scientists are also exploring non-traditional methods like using gravity fields and geomagnetic fields for navigation. These could offer highly precise, efficient, and reliable alternatives for deep-sea explorers. And let's not forget communication. Better underwater wireless communication, including using light, yes, optical communication in the deep sea, and developing long-distance, high-speed underwater communication is critical. This helps AUVs send back data and work together on complex missions. Despite all these amazing breakthroughs, navigating the unmapped deep sea isn't a solved problem. Accumulated errors from those INS systems are still a headache, often forcing AUVs to surface for a GPS fix or rely on acoustic beacons, which isn't always practical. Plus, while terrain-aided navigation is great, it needs good maps, and guess what? More than 80% of our ocean is still unmapped and unexplored. The deep sea is also a constantly changing, complex place, making precise navigation a tough, ongoing job. And even with advanced sensors, we're not quite at perfect underwater robot vision yet, and processing all that data takes time. So, what's next for these intrepid underwater robots? The future looks even more autonomous, with AUVs that can better perceive their environment, plan their own routes, and make complex decisions. Get ready for swarm robotics, networks of multiple AUVs working together to cover vast areas and collect data more efficiently. Engineers are also pushing for AUVs that can dive even deeper, potentially to the full depth of the ocean, around 6,000 meters or more, and expect them to get even smarter with next-generation AI. We're also seeing more modular designs, meaning AUVs can be kitted out with different sensors and tools for specific missions, like a Swiss Army knife for ocean exploration. The journey to conquer the deep sea is ongoing, and these evolving AUV navigation technologies are leading the charge. They're opening up our planet's final frontier, not just for incredible scientific discoveries, but also for the sustainable use and protection of our precious ocean resources. It's a new age of exploration happening right now beneath the waves. That's all for this episode of Fun Facts Online. Join us next time as we uncover more fascinating facts from the world around us. Until then, stay curious.